All right, let's get going. Let's see. Okay, let's chat about the what today. I'll turn down this music a bit. So the what. We're not touching that damn PowerShell right now. That is not a problem I'm going to handle. Luckily, we've got lots of pieces to build out, so we don't need to touch the PowerShell right now. And I don't want to, and that made for an awful stream last night. So we're gonna work on some fun stuff, like enumerating processes on the target system, establishing persistence, and reading from the registry. Not gonna do anything super fancy, just gonna kind of set up the basics to kind of show how it can work on the very basic level. And then we'll start getting fancy later. Do some actual Windows API research, figure out like better or more sneaky ways to do this stuff. So let's go over to screen recording. So like I said, goals for this one. Process enumeration working. Definitely going to copy to startup. That's fun. And we probably will get to the registry data enumeration. I'm trying not to make this a super long stream. I was up until like 4 a.m. this morning, so coffee is only going to hold me on for so long. Let's get started. So we were actually working on process enumeration yesterday. That's not what I need. Streaming. This. And I got it working off stream actually. So if we go to make clean, clear screen, make, we've got it building, should copy itself over to data. We're not going to, so we can actually go to our victim here, and instead of doing the PowerShell shit, so Lord knows we're not messing with that right now, we can just open it up here. So we're gonna copy it over to temp. Right. And let's see. Should be main.exe. Yeah. Main.exe. So we've got 136 processes. That sounds about right. Not 100% sure. That sounds about right. Can we open, actually, let's see. Let me open this. Z is what it is. It's the Z drive. Nope, you can't. It looks like that sucks. If we could open the Z drive, we could run all of this from Z drive instead of having to copy it over every time. But can we do this? Nope, that doesn't work either. That sucks. Whatever though. So let's see. What's next? This is what I needed. / main.exe. Yeah, okay, so that works. So we can just keep running it that way. All right. So we've got the number of processes running. It's actually a fairly convoluted process to get the process names and the PIDs. Well, I think the PIDs you actually get. Let's open up the MSDN documentation for enumerating processes. So this is actually not the official MSDN docs for enum processes. That is this right here. Yes, you actually get a pointer to an array that receives a list of PIDs. So we can print out all of the PIDs if we wanted to. So that's the number of processes. It's in count process or C processes. Where's that being? Oh, it's right here. So for int I equals 0, I is less than C processes I plus plus, we're going to print out all of the PIDs. And that is going to be, I believe, a %d. And I'm going to pass in. So it's not going to be is it just the, I mean, we can just try it out. LPID process I don't think it's that easy, but we can try. Like clean. I think it's going to end up being I times the size of a D word, but I might be wrong on that. I'm not entirely sure how all this stuff is stored. Well, we can give it a shot. Oh, damn, that worked. Huh. Okay, cool. All right, so we've got all of the PIDs. And what we're doing here is, let's rewind, since all this stuff may not be new to everybody here, or may be new to everybody here. What we're doing here is we're creating an arbitrary size here, which we're not actually testing for. Let's see, probably ought to test for that. Printf needed bytes, %d, and I think it's CB needed. No, it's bytes needed, I think. What is it? Needed bytes. Oh my gosh. Now that ought to tell us if we, that will tell us if we actually need a larger sized array or not. I accidentally ran that from my host system, which is good. Very good stuff there. Something you definitely want to try your best to avoid at all costs. So let's scroll up to the top. Needed bytes 496. So what I believe that means is we actually don't need as much space as we have, but let me make sure of that. That could either mean we don't have as, we have more space than we need, or we need 496 more bytes. The number of bytes returned. Okay, so we've got enough bytes is basically what this is saying. So that's the number of bytes returned in the P process IDs array. So the actual size of this LPID process, the actual size needed is 496 bytes. Now, we don't know that whatever system this malware lands on is going to just need that amount of space. So we want to go ahead and like allocate more because it's fairly cheap anyways. This is only 800 bytes here, you know, so it's a very cheap, you know, amount of address space that you're using there. So now that we know we've got enough memory there, we are looping over the PIDs, and now what we want to do is ** get proc info. All right, so get proc info is going to return process information. And we are going to return it from a dword PID. And that doesn't need to be, okay, that linter took way too long. It doesn't need to be a pointer or anything fancy, it is just a PID. So, if we go back over here, enum process modules is the next thing that we want. We want to actually open up a handle, and that handle is going to give us the information that we actually want. I filled this damn coffee to the brim, man. I need every ounce of it. So, enum process modules is what is going to give us the actual like information about the process, not just the PID. Because we're going to get all of that information from a handle. So that H process is what we're looking for. No, that's a handle of the process. That's not what we're looking for. We want to open up the process first. So let's see what they're using for that. So yeah, so that's actually opening up the process itself. Here's main. So this is what we've already done right here. This is getting the PIDs. So let's go ahead and comment this code here. So get PIDs. It's making sure that the PIDs are actually gotten. Actually clean this up a little bit. Let's just pull all of this out. If that equals 0, then we will return one. We can get rid of this else now. We can just run everything one small indent in, which really doesn't make that big of a difference, but it makes it look a little bit cleaner. And we can comment a little bit easier. Grab the count of processes. That's going to print out our information. Then we are going to loop over each PID, print out process information. All right. So the process information is basically the next part that we're gunning for. And to kind of flash forward, my plan for this stuff is we're going to get our process information. We're going to get user and system information. We're going to get some network information. We're going to dump all of this out to a file, like a binary file, and we're going to just ship that away to our C2. Then our C2 is going to decode that on its side and find out all of the fun and cool stuff that, we want to know about our victim. So next up is going to be carstar proc info is equal to get proc info with the LPID process I. So that's just going to actually call the function. Let's go up to get proc info. All right. So we could just straight up copy paste all of this shit right here. Wouldn't necessarily be anything wrong with that. In fact, we're going to do that, and we'll just comment on it, basically. I'm going to refactor it a little bit because their code, Microsoft knows what they're doing, but I don't like the way it looks. Process ID is a little bit long. So tchars are one of the things that annoyed me my last run around with this. It's so difficult to explain them correctly. So basically a wide car. Okay, we're not going to worry about that right now. Let's look at this code. So we are actually getting the process name right here. This max path I don't have defined. So we're just going to throw, I guess we'll just define max path. Let's just call it at 800 because we've used that already. All right, so max path is defined now. Oh wait, that may be a system variable now that I think about it. Yeah, so that's 260. So that's actually a system variable. So that's going to store like basically empty text there. We're going to open the process here, get a handle to it. Then we're going to get the process name by enum process modules. So this was the part that was weird. So we're opening up this process we just opened up with that PID. We are storing the process or the handle for that module in hmod right here. That's just the size. And CB needed, I'm assuming, is the size that we would need. So as long as that works, this is going to get the module base name. Get module base name. Oh, let me go back here. I wish these were clickable. Let's do SDN get module base name. Right. Also, I believe somebody said to zoom in on the code. Is that big enough? That's too big. I'm not going to deal with that. So get module base name. What does that do? Retrieves the base name of the specified module. Wow, that's super useful. Primarily designed for use by debuggers and similar applications that must extract module information from another process. If the module list and the target process is corrupted or is not yet, blah, blah, blah. To retrieve the base name of a module in the current process, use the get module file name function to retrieve the full module name, and then use a function called blah, blah, blah to scan in the beginning. This is more efficient and more reliable than get module base name with a handle of the current process. Interesting. So, what is a module base name? I remember doing this before, but I want to make sure that I actually understand it. Does API. What is a module base name? Windows API. What is a module? So this might explain it. Program itself and all of the dynamic link libraries loaded with virtual memory space are called modules. So that is basically the module base name as I understand it. I think the module base name is the name of the binary being run. I want to say that's how you can describe it. Don't quote me on that, but I'm pretty sure that's correct. So get module base name, that is going to store it in the process name there, and that tchar. And then we're going to return it here, but that's going to print it, sorry. But instead of doing that, we want to return it. So after we close the handle, we're going to return. Might have to cast it, we might not. SC, what was it? So this is why I don't like having my window zoomed in this much. SC process name. That is not a pointer right now, I don't think. SC process name. Let's see if it's going to let us just simply cast it that way. I want to say it will. Right now it's not complaining. So let's try to print that. Printf. Module base name. Then I believe it'll be %s. And we will do proc info. Now, since there are pointers involved in multiple functions, I can just about guarantee that I'm not doing this correctly right now. But we'll give it a shot. Let's make clean first, just make. I can just about guarantee this is not going to work perfectly. Actually, just because I'm going to be a little bit nitpicky here, for PID %d, we're going to do lpid process at I. That will print out the PID and the module base name all in one. I go to a new line. Let's make clean, make. Let's see if there's just some like magic that allowed me to actually do this correctly first shot. Just about guarantee it didn't. Yeah, no, something broke. Something for sure broke. Huh. Let's try to run it on our system. Yeah. So there we actually needed more. We needed 1500 bytes instead of 800. So it actually wasn't going to print all the information we needed there. But that's no big deal. So let's see what we did wrong. And unfortunately, since again, we don't have a debugger here at the moment, I'm not going to kind of play around with that at the moment. Let's see if it's in the print or not. We can just do a quick exiting get proc info with PID %d PID. Let's see if it's the print that's the problem, because sometimes that happens. Is that throwing errors that I'm missing here? Yeah, it's throwing some errors. Make clean, make functions returns the address of a local variable on line 36. That might be a problem. Yeah, it is. So instead, what we might want to do is make this a void function and write out to an address that we supply here. So tchar proc name. We're going to pass that in. Proc name. We're going to pass in a pointer to it. That may not work. No, the address, proc name. Let's see. Then we go back up to get proc info. We want a tchar pointer, proc name. Now, instead of this, we are getting a void get proc info. We are going to write out to that address. Let's see. So instead of this, just replace that with proc name. That might or might not work. We're going to give it a shot though. Basically what we're doing here is instead of returning a value or returning a pointer to a value, we are just writing over that space in memory that we're supplying from the main function. That's a super common, I guess, method of doing this. And proc name, we'll go ahead and give it the max path size. Don't need to assign this anymore. We just need to run it. And this needs to be pointer to proc name. Or dereferencing proc name. No, I'm doing this wrong. No, I'm not. Might not be doing this wrong. Make clean. Make. See if it complains. Yep, it does. Returning an int from a function with return type car. What? Process 5116. Is this? Oh, you're right. We can just return. Yeah, we can just return void, right? Does this really need to? This can be a void function, I believe. I come here just to say hi. It's late here. I need to go now. Good luck, bro. Mahad, you're the bomb, man. Take it easy. I appreciate you showing out. It's late here too, so I get it. So now that's a void function. That shouldn't be an issue because, yeah, we're calling it as a void function, so that's totally fine. So let's see if that got rid of that error. Should have. Didn't. Here, I'm going to start, let me exit out of here. We're going to start just running it here. All right, that's much better. Function enumprox, passing argument to of get proc info from incompatible pointer type. So that's a pointer to a tcar. Expected tcar pointer, aka car pointer, but argument is of type tcar pointer 260, aka car pointer 260. Why is that a problem? It shouldn't be. Return with a value and function returning void. So that's an easy one to fix. 66. So that's just an enumprox. Return. We don't need this anymore. All right, that should have at least cleared up one of the errors. Make clean. All right, so we cleaned up one of the errors. Passing argument to get proc info from an incompatible pointer type. Just. So do I have to specify a given size within here? That shouldn't be a way that you do it, but it might be. That'd be kind of weird. Within the function definition? No. that caused so many other issues. Yeah. I was about to say, that just doesn't look right. For some reason I had this idea in my head that I'd been streaming for like 30 minutes and hadn't turned on my mic. And people were just watching me like talk to a camera voicelessly. Glad that didn't happen. All right. So we're still running into this. I mean, it's a warning, so we could technically ignore it. Expected tcar pointer, but argument is of type tcar pointer 260. Is that big of a deal? Let's just run it and see if it runs correctly. No, it didn't run correctly at all. So it failed on PID 0. I think it's the printing that's the problem. Yeah, actually I know exactly what it is. I think I know exactly what it is. Let's go back to our MSDN article. Let's pop that open real quick. And it used a special print function. Let's see. I believe, but that shouldn't matter. Yeah, right there. tprintf text. I mean, like, I should be able to use printf to print a character pointer. I should be able to cast it the way that I'm doing it too, but it may be the casting that's the problem. We can test it pretty quickly. Before print. So this right here is a %d. That's the process ID. There should be no problem there. It's got to be that proc name right there. Printing out that proc name is causing problems. Let's do... Can we cast this as car pointer? Is that a thing that we can do? So we're dereferencing it, and we're calling it a car pointer. That doesn't sound like something we can do, but we're gonna give it a shot. Yeah, it's probably gonna complain about that. Cast to a pointer from an integer of a different size. What? An integer? What are you on about? None of that is an integer. Let's see. Haha. Okay. Progress has technically been made. Doesn't look like it. We are needing another new line. So it's printing now. It's not printing anything useful. Let's try that. Just kind of throwing stuff at the wall to see what sticks at the moment. It may sound familiar to those of you who have watched for a little bit. Right. Yeah, that just straight up failed. So we were closer, I believe. So let's just try. We need to basically cast from this tcar array over to a car pointer. And my understanding is they're basically the same. Yeah, they're a pointer to a character. So I'm just gonna be a noob and straight up Google it. Print F C print a tcar. We're not using C++ here. I'm just using straight up C. Yeah, so they're showing that tprintf as well. All right, whatever. We'll use tprintf. We can actually... Yeah, so this actually won't be that bad. Basically, we just won't create a new line here. tprintf. Is it just tprintf? Where's tprintf coming from? Oh, it's from tcar. Include tcar.h. Then we'll have what issue are we? Oh, we're missing a parentheses there. And tprintf. All we're printing is just the proc name. Let's do it this way. What's it asking for? This is such a weird syntax that I don't understand. This is going to be something that I'll look into later. Percent s/n, and we're doing it here. Proc name. I don't think that's a pointer that we need to dereference, but if there's an error, then we know that's probably what it is. So let's hop over, make it. See if we run into any problems. Surprisingly, no. Run it. Yeah. All right. But it's truncated, which is weird. Huh. And these are just completely wrong. That's interesting. It's just printing nonsense there. Okay, so we're going to write that down as a fun error. Fun error. Process names are truncating and are sometimes nonsense. Because C, why not? All right. So we are sitting at 37 minutes. What I've noted is that close to nobody actually sticks around for much longer than 30, 45 minutes tops. So I'm going to call it there. And we're going to do, actually, before I switch to face cam, whatever, let's do a quick review of the code. So, starting off in main, we are including includes.h, which if we pop over there, includes the definition for enumprox, which you can find in somewhere, processes.c. So enumprox, right here. This right here is going to enumerate all of the processes and store a pointer to an array of those processes, or a pointer to an array of the process IDs right here. Maximum of 800 bytes worth of PIDs. Then that's just the size of the LPID process array. And this right here is going to tell us how many bytes we actually need. So if we go back to our print, I don't know if I'm actually still printing it. Yeah, so we need 496 bytes, and we gave it 800. So we've got more than enough here, but here we did not have enough. I think it needed like 1500 bytes or something like that. So this is making sure that it actually runs successfully, and this is calculating the number of processes. So that is the needed bytes, the amount of bytes that we actually needed to store, divided by the size of a D word, which is the size of one process ID member of that array, basically. So that's going to give us how many actual processes or how many PIDs we're actually storing. So printing out that information here, then we're running over each one of those processes and we're calling get proc info on it. What we're doing is creating basically a pointer to an array of process names. Wondering if the fact that that's not an array of process names, that's a pointer to just, yeah. So that's not an array to a process name, to process names. That's just a pointer to a space in memory that we can store one process name. So we are giving it that address as well as the PID. Pop on over to get proc info. We've got our PID. We've got that pointer to our process name. And we are opening that process and receiving a handle to a process. Do you have any tips for beginner malware developer? Cool, glad you asked. Give me like 3 seconds and I will absolutely give you some. Because I've got a solid rant on this. So this right here is going to open up that handle. Handles are basically ways that you can actually access processes. So we are opening it with query information and reading the virtual memory. We don't need any write access here, so we don't need to actually request it. So we're getting that information later on down here, but we are using the PID that we passed into the function in order to get that information, open up that handle. Storing process IDs, do you think using create tool 32 snapshot to create a snapshot of the processes is better? Possibly. So store that thought, Baba, and XVA, I owe you a rant. We're going to get to that here in a second. Let me finish explaining this and then we'll get to it. So this is making sure that we actually successfully open up that process. We create a handle to a module, and we create basically a way to store the amount of space that you actually need to open that module. I believe that's what it is. I'll have to look into that. I might be that didn't sound right, but I'll look into it. So we're opening up we're basically finding out how many. Okay, I'm not speaking correctly. We are enumerating over the modules in that process. The modules being like DLLs and executables and things like that that are associated with the process that's running. We're using the H process right here with the open process that we just opened with that PID. We are passing it in the HMod for it to basically store the return value. We're giving it the size of the HMod, and this is going to tell us whether or not we needed more space. The get module base name is going to give us the base name of the module that basically started the process, so the executable that started the process. I think I'm going to do some checking off stream to make sure that I've got that right. So this would be printing the process name, but I got rid of that. And don't need this anymore. We're closing the handle here and we're good to go, because the way we did this was we passed in that proc name pointer, and this right here is storing the name of the module base in that memory address. So we don't actually have to return anything. So here is where we are printing out things wrong. Okay. So this will be either off stream or somewhere. Rants. Baba Lamanu, I'm starting with you because the answer to your question is the most simple. There are probably plenty of better ways to do what I'm doing right now. The purpose of this is to do things the most simple way possible, or the way that MSDN just blasts out to you, and later on figuring out new and better ways to do it. The whole purpose of RRE is to basically figure out hey, here's the dead simplest way to do all of this stuff. How would a junior very beginner malware developer like me do it? And then let's figure out how to evade defenses. Let's figure out how to hide a little bit better. Let's figure out better ways to do this, more efficient ways to do this, more sneaky ways to do this, all of that. So create tool help 32 snapshot is a method that I've heard about. I have not done much looking into it, but that's going to be later. We're going to figure out that kind of stuff and figure out if it's the best way to do it. All right. So I'm going to write down that I'm starting this rant right now. So malware dev rant start at 44:44. Okay. So beginner malware developers wrote a blog on this actually today-ish. Sorry, that's a book that I'm reading. ValhallaResearch.net. How to develop good malware and software in general. So let me share the link to that blog real quick. So basically my thought process on it is this. If you want to become a better malware developer, you have to develop more malware. You have to read more malware source code. You have to become good at different stacks. Stacks being C, C++, Rust, Windows API, Linux, all kinds of stuff. I've got tons of more granular explanations of all of these pieces of advice, but what it all kind of boils down to is this. You need to focus on becoming a better developer. Don't focus on becoming a better malware developer specifically, even if that's the most fun thing to you. It's enjoyable to me too. That's why I live stream it. but you need to become good at development, which is why I do all kinds of weird projects. It's why I'm like writing web apps. It's why I'm thinking about like doing graphics coding and things like that. Like, you need to focus on becoming a good developer and understanding development, and then apply that to your pet projects. So apply that to writing malware, apply that to, writing web applications, apply that to all of these different things that you want to do. And that blog that I just shared that I spent entirely too much time writing last night basically like breaks down a roadmap on how to do that. And because it was like a super long blog, I'm not just going to completely like read from it. But essentially one of the like biggest pieces of advice I have for you is to go out and like write as much software as humanly possible, and to dive into the docs and really understand what it is you're looking at. And that's going to really help you a lot in kind of your journey, because one of the biggest mistakes I made early on was, I'm going to write malware, I'm going to become a good malware developer, and I never learned C, and I never learned C++, and I never learned the Windows API. And now I'm having to learn all of that stuff, and I'm, doing it live, which is why, it's going very slowly. But, that was a big mistake for me early on, was focusing on, I want to be a really good malware developer, and not, I want to be a really good developer. I want to focus on writing malware in C, and not, I want to focus on like learning C. Like I just showed you, I don't know how to explain what a TCHAR is. I should. I'm trying to like live stream this stuff. I should know how to explain what a TCHAR is. But the essentials of it is, don't focus on like becoming a good malware developer. Focus on becoming a good developer that develops malware sometimes, or all the time. I don't care. You do your thing. But yeah, that blog, I think, obviously I'm biased, but I think it's a really good roadmap on kind of how to learn and how to become a better developer. I'm missing stuff. I actually noted at the very end that this is probably going to be a living doc, or I'm going to like publish updates and things like that. So don't like read it like the Bible. It's just something that might like be a decent guide for like how to become a better developer over time. But really, like at the end of the day, code, write tons of projects, read tons of code, read the docs. God, just read the docs. Like that can help you so much. Read the docs deeply and understand the docs, and like really like focus on understanding what's going on there. Because again, I made the mistake of not doing that, and now I'm kind of kicking myself over it. All right, questions. I'm going to call you XVA, but I really want to call you Ziva, because NCIS. That was a long rant, I guess, sort of. Let's see, how long did I go on there? That was only like 5 minutes. That's not too bad. But yeah, TLDR, just become a good developer and write tons of code and really like get into the science of it and really get into understanding it, and read my blog, because I write about stuff like that. But yeah, I'm also going to be publishing some malware development stuff on that blog fairly soon. Basically I need to like transcribe all of these streams into something that's a little bit more understandable and like good for writing. So that'll come eventually, but I'm not super focused on getting that out quickly. Yeah, appreciate all of y'all showing up. It's been a more lively stream. We're gonna end it there and focus on persistence, registry stuff, figuring out that weird bug with printing out the process names. Yeah, later. Peace.